Okay, here we go. Unit 6, lesson 10. All right. Translating lines. So draw any non-vertical line in the plane, okay? Okay. I'm just gonna pick a couple points. So let's go like here. And over here. I'm filming this live in class. Students are quietly working. Just an FYI. Okay, so you got this point and this point. Now, we checked off that first part. Now we're gonna draw two possible translations of the line. So why don't we just like move each point up 2 units. That'll be 1. And then I'm gonna do, we're just gonna go down 3 units. So 1, 2, 3. All right. 1, 1, 2, 3, right there. Okay. So we did the 2 translations. All right. Now we have to find the slope of the original line. That one's in black. So let's just do that. As you can see, the rise, we're going to use this point and this point. So I'm going to draw this little right triangle right here. So the rise is -3, and the run is 1, 2, 3, 4, 5. So again, the rise over the run is -3 over 5. Okay, let's look at the blue one. We're gonna go from this point to this point. Check this out. The rise is 3. So rise over the run. The rise is 3. Now we're here, we're going 1, 2, 3, 4, 5, but we're going left on the x's. So that's 3 over -5. Now let's do this one. Go from this point to this point. This one's pretty easy. We just did it. The rise over the run equals -3, and then we're going over to the right 5. So -3 over 5. Now observe this. All 3 lines have the same slope of -3 over 5. Nice job. You're gonna learn something new. Parallel lines have the same slope. Okay. 10.2. Priya writes a proof saying, consider any 2 parallel lines. Okay. These 2 right here. Assume they are not horizontal or vertical. These are diagonal lines. All right. Therefore, they must pass through the x-axis as well as the y-axis. X-axis and the y-axis. This forms two right triangles with a second congruent angle. Call that angle theta. Okay. So you got like a red triangle right here. And you got like a blue triangle right here. Okay. So those are the triangles they're talking about. All right. The tangent of theta is equal for both triangles. Okay, that is given. All right. Therefore, the lines have the same slope. Okay, that was Priya's proof. Now, how does Priya know the right triangles have a second congruent angle? Well, look at this x-axis right here. I'm going to draw it again. You got two parallel lines, and the x-axis is a transversal. So you got two parallel lines, and the x-axis is a transversal, right? Because it cuts across two parallel lines. Work on that third problem before I leave. You can work together if you want. See if you can do it, and then we'll get to it. Okay. And I'm about to get to that soon, so you might overhear me. Okay? All right, so two parallel lines, and the x-axis is a transversal. These thetas are congruent because that creates an angle relationship known as alternate interior angles are congruent. Alternate interior angles are congruent. Because of this transversal across two parallel lines. Show or explain what it means that the tangent of theta is equal for both triangles. Okay. So what they're saying, they already gave you that the tangent is equal. They're asking to show or explain. So let's just call this A, call this B, we'll call this C, and we'll call this D. So what it would say is that tan theta equals, let's start with the red triangle. Opposite, remember TOA? So opposite is A, adjacent is B. And tan theta over here, opposite is C, adjacent is D. So that means A over B will equal tan theta, and C over D will equal tan theta. And because they gave you that these are the same, you now know that A over B equals C over D. Now, number 3, how does this prove that the slopes of parallel lines are equal? Well, let's look at A. A is the rise. B is the run. So rise over run is A over B. Right? Let's look at C. C is the rise. What is D? D is the run. So A over B equals C over D. A over B is rise over run. C over D is rise over run. What is rise over run? Slope. That proves that the slopes of parallel lines are equal. How cool is that? All right, one more. Prove your parallelogram. Okie doke. Let's see if I can get a coordinate plane here. Yeah, we can draw one. So. Okay, here we go. Write the equation of a line parallel to y equals 2x plus 3, passing through negative 4, 1. Okay. So for this, you need to use point slope form. This is slope intercept form. That's slope intercept form. We're gonna use point slope form. Now slope intercept form is y equals mx plus b, where m represents the slope. So we learned that parallel lines have the same slope. So point slope form is y minus k equals m x minus h. So if it's parallel to this line, then m has to be 2. And because we have a point, that's why point slope form is so helpful. All you need is a point, any point, and the slope. So it's whatever zeroes this out. So it'll be y minus 1 equals 2 x plus 4. So y minus 1 equals 2 times x plus 4. Now graph both lines described in the previous question. Both lines. So we got to do this one and this one. Now, my table of 4, there's the graph. See it? You gotta maybe even create your own set of axes. It's kind of tough because you don't have graph paper. Actually, let me give you graph paper. Okay, here we go. Just realized my homework completers needed some graph paper. Alright, y equals 2x plus 3. Let's do this. Let's make these half marks. So 2x plus 3. So let's say 1, 2, 3. Y-intercept is 3, right? And if the rise over run is 2, then rise 2, run 1. Right there. Rise 2, run 1. Folks who didn't complete their homework, this is not your time to take a nap. It's not the time to take a nap. It's time to wake up and catch up. If I look out and I see you taking a nap again, I'm not going to be happy. Could be time to go to the office. Because you're not doing your homework and you're sleeping now. Okay, that's 2x plus 3. Now, this one, we know it goes through -1, -2, -3, -4, and 1. Rise 2, run 1. Same slope, these are going to be parallel. Okay. Now, draw a parallelogram using the two lines, which are parallel. You gotta give me that. And using -4, 1 as one of the vertices. Okay, so we're gonna use that point. Then we're gonna use -1, 1. Connect these. Shade it in if you need to. And then we have to prove that it's a parallelogram. Okay, well, I already know these two lines are parallel, so that's parallel to that, right? Y. So we'll just call this line A, line B. Line A is parallel to line B. And the reason is same slope, right? Now, this is parallel to this. Why? So these two are parallel also. Why? Because horizontal lines on the coordinate plane are parallel. So horizontal lines in the coordinate plane are parallel. Okay, so that's one of the qualities of a parallelogram. Opposite sides parallel. Now, how can we prove the next thing? That opposite sides are congruent or the same length. Well, that's pretty easy. If you look closely, the grid would have helped. We've got right triangles here. Here and here. This is 2, 1. This is 1, 2. Meaning that this side, we got another right triangle, is going to be the square root of 5. Each one of these is going to be the square root of 5, because 1 squared, which is 1, plus 2 squared, which is 4, so 1 plus 4 equals 5, will equal c squared. That's Pythagorean theorem. So these are both square root of 5 right here. These are easy. These are both 3. You can just literally count them on the grid. So there you go. 3 square root of 5. Opposite sides parallel. We proved that over here. And we just proved that the opposite sides are congruent. So that, my friends, is a parallelogram. And reminder, do your homework so you can join us for the next lesson.